even more important than being able to make graphs is being able to analyze them, being able to describe them and the data set that they are displaying. So one of the first things we need to talk about is the shape of the graph. Okay, so there's a couple different ways you could describe it. One is symmetric. So basically, the right side of the graph is very similar to the left side of the graph. Now, almost no graph that you look at that contains real data is going to be exactly symmetric, but we're looking for roughly. So there's the largest bar or stack of dots is in the middle, and then it goes down on both the right and the left sides at about the same pace. Okay? If a graph is skewed to the right, it means that there are little smaller tails or outliers out to the right. Okay, so the center is over here, and then this is going down nicely, but over here it keeps going a little bit further. Okay, same thing, we can also have skewed to the left. All right, it's a little tricky here. It's like the opposite of what you would think. All right, but the direction of skewness is towards the long tail or the where the smaller dots are. Okay, so if we think about this, most of my dots are over here, and then this one out here is like messing it up. So it is skewed to the left because this guy is messing up my symmetry. Okay, so it's kind of the opposite of what you would think. It's where the longer tail, usually with the smaller bars or stacks of dots, are, that's the direction that the graph is skewed. So when we are asked to describe the distribution or describe the graph, because that's what a graph is showing us, is the distribution, we're going to look for four things. Okay, shape, which we just talked about, center, variability, and then any outliers. Okay, and we have this little tip here. Make sure that you include context, meaning units. All right, so we can't just say the number two. We have to say two people, two hamburgers, whatever we're talking about in that graph. So we'll look at an example. So here we have a distribution of goals scored by the 2016 U.S. women's soccer team. Okay, so when we talk about shape, the distribution we would say is skewed to the right because we have most of our stuff over here and then these two guys out here that are kind of messing up our symmetry. All right. There's a single peak at one goal. What that means is the highest point is right here at one goal and there's nowhere else that it's equal to. If like let's say 3 had scored the same number of goals and had that same number of dots, we would have 2 peaks. All right. And then we can say there's a gap between 5 and 9 goals. All right. Because we have 1, 2, 3, 4, 5, but then they never scored 6, 7, or 8, but they did have a 9 and a 10. Okay. Those 9 and 10 look to me to be outliers. They are way far away from the rest of our data. When we talk about the center, we're talking about the median. All right. And remember, that's the middle number. So if you remember from middle school, like crossing out numbers, you can also cross out dots. Okay, so we have 1, 2, 3, 4, 5, 6 dots here. So if I cross off 1, 2, 3, 4, 5, 6 dots there, then my middle is going to be somewhere in here, so it's going to be 2. And then when we talk about variability, we're just talking about how's the data spread out. So all of the goals scored numbers are between 1 and 10. All right, so check. Would this answer work well for an AP exam? Did it include context? Yes. Every time they said goals scored or they talked about goals and the games when they scored. Okay, we're not just throwing numbers out. The other thing that we want to be able to do is compare distributions. So we have two graphs and we want to compare the two. We're still going to look at those same four things, the shape, center, variability, and outliers. But we're going to compare those two. All right. And so when you do that, we don't just want to like talk about the graphs individually. we want to compare them using things like greater than, less than, or about the same. Okay, so here's an example. We have graphs for household size in South Africa and then household size in the UK. And so we go through each of those things and we want to compare the two. So when we say shape, the UK distribution is roughly symmetric, all right, and it has a peak at 4. And then the South African is skewed to the right because of these things down here. It also has a peak at 4, but then there's a gap from 15 to 26. Okay, when we talk about outliers, we say the UK distribution down here doesn't appear to have any outliers, but this one does at 15 and 26. And then here's a good thing where we talk about comparing. So household sizes for the South African students up here tend to be larger than for the UK students, okay? UK is bunched in here, and then the South African numbers are a little bit bigger. Then variability also has some good comparison. The household sizes for the South African students vary more. They go from 3 to 26, whereas the UK is everyone was between 2 and 6. Okay, so same things. We still want that context. We're using the word students over and over again. We're talking about sizes, but then we're also comparing the two. We're not just individually analyzing them. We are comparing the two directly. Okay, and that's it for the analyzing part of graphs.